Next, binary search implementation or binary search algorithm implementation. We already know linear search, that means searching an element from start to end is called linear search. Searching for an element from start to end of the array. If it found, returns index, else returns -1. In binary search, we are dividing the array into two parts based on the middle element. For suppose int array, let's declare with the 1 3 2 5 8 7 9. We have array like this. It should be in sorted order. First condition, sort array. Once you sort it, let's display the array first. Arrays class has method called sort. It will sort the array. First compile it, and before that let's display sorted array. Arrays class has toString method. It will convert array into string. It will display java c -cp dot bin search. Execute it -cp dot bin search. This is the sorted array we have. Let's copy this. Sort array is that one. We want to find out element k in that, like int k equal to, let's take 1. So the search should give index of element k, that is 1. So the index is going to be 0, right? How can you find out? First, it divides the array into two parts based on k element. Before that we need to find out mid of the element, that is middle of the element, based on formula, that is starting index is 0 and ending index is a dot length divided by 2. So mid is going to be starting index is 0 plus ending index is 5. So we are taking a dot length, that is a 6 by 2. That means middle element is 3. That means from 0 to 3, here 1 2 3 5, whether k less than a of mid, yes, then search in this array only, in this portion of the array. Let's take 9. In that case, whether k greater than mid, a of mid, in that case search from mid plus 1 to here, that is 7 8 9 only in this area. And if it found a of mid equal to k, no, and that again it divides the array into two parts. Again it divides the array into two parts. That means a until a of mid equal to k, this array is going to be divided. Okay. Finally middle element is going to be k. At that time it returns the index. Index is nothing but a middle element. Okay, let's write a program for this. We already calculated mid element and k9 also. If k equal to a of middle, then print it. No need to search further. Printf element k equal to percentage d is found at index equal to percentage d, that is k comma mid. Else we need to binary search it. Let's display this first. Before that we can read this value from the scanner class, because we are going to search many elements. Read from value from console using scanner class. Scanner class has method called next int. Assign that value to k. Before that, display some message system.out.print. Please enter the number to binary search. Now compiled, made this syntax error, semicolon. Execute it. Please enter the number. Before that we need to display the array so that it is easy. Where we are displaying here, before that itself we need to sort and display that number here itself. Now it will be good. That is the original array after sorting. Middle of the element is at 4 is 5. Let's element to search. Element is k equal to 5 is found at index 3, right? If not found, we need to do binary search. Else, what is the class name? Bin search. bsearch serc. We need to pass array starting index and ending index, that is nothing but a dot length, and element we are going to search. This will return an index. Let's declare another variable, index equal to -1. Copy it, /n/. Element k is found at a index. Let's write a binary search algorithm. Int bsearch, it takes 4 parameters. First is array, second one is start element, third one is end element, and the fourth one is last one is the element we are going to set. Let's declare temporary variable in index equal to -1. If start greater than end, return index. Here also we need to find out at the end also return index. Here also we need to find out middle of the element. This formula only, but something different, that is end minus start and mid equal to start. Why? Because if you are going to set second half of the array, in that case end is 6 minus start is middle element 3, 6 minus 3 3 it will give. So that means you are going to set these elements, so not this elements. 3 means again it comes here. In that case we need to add a start element. So here if mid element greater than equal to start, or mid is less than end, return index. That means that element is not found, otherwise it keep on divide the array, it goes to infinity loop. If k equal to a of mid, return middle element index. If k less than a of mid, again we need to binary set start element is going to be start only, end element is going to be mid minus 1, because this condition failed, it will come here, and element is going to be k. Else we need to set from mid plus 1 to end of the array. So start element is going to change. Start element will be mid plus 1 and end is going to be same element you are going to set. Both functions return index equal to, right. Here we need to put this in braces. Let's compile it. No errors. Java -cd insert element we are going to set 3. 3 is found at -1. Let's debug. Here small mistake, it is greater than equal to start. We need to replace it's going beyond lower index, it is going, if it is going higher index, and these are all same. Let's compile it. Java -cp dot. Let's find out one is located at index 2, index 1, 3, index 2. We are going to find out 4. That element itself not there, we should get -1. -1, 5 is there, 6 element is not there, -1, 7 is at index 4, 8, index 5, 9, index 6. We are going to find out 10 by entry. Index is at I will fix that. Mid is greater than or equal to, and return -1. -10 -1, and is equal to, greater than or equal to. We are going to find out 0. 0 is found at index -1. Yeah, that's it.